problem we're going to look at sine of x is equal to square root of 3 over 2. So when we're looking at that, make sure to remember what we're trying to do. We're trying to solve for x. So x is the angle that we're looking for. So in order to solve for x, we have to divide both sides by sine. And in doing so, that leaves us x on the left side. But on the right side, we have a special name for this sine. It's either sine to the -1, or we can put what? Arc sine of the square root of 3 over 2. And by definition, arc sine the square root of 3 to 2 is the same as sine square root of 3 over 2. So that means we have to go to our chart and look for where x, or sine, is equal to square root of 3 over 2. And there are two different possibilities, 60 degrees and 120 degrees. So x equals 60 degrees and 120 degrees, and that's your answer. Also, in working with the inverse relationships, remember anytime you have an inverse or a ratio times its inverse, tangent times inverse tangent of, let's say, 3. Remember, tangent times inverse tangent equals 1. So the value, or the answer to this, is going to be 3, because 1 times 3 is 3. So anytime you see that type of relationship, remember it can be tangent, or in this case it can be written as arctangent, arctan. Those are synonymous with each other. So when you see that, that's a 1, so all you have to do is focus on that number. Now the problem comes when you have something like this. You have the cosine, or the arc sine, of 2 over 3. Remember, by definition, arc sine 2 over 3 is the same as what? Sine 2 over 3. So that means we have a right triangle, and just pick an angle, it doesn't matter, so we're going to pick this one. So that means the sine of this triangle is 2 over 3, so this is going to be 2. That's our opposite. Remember, that doesn't touch the angle. And 3 is the hypotenuse. So if that's the setup for this triangle, we need to find this missing piece here in order to be able to answer cosine. So we use the Pythagorean theorem since we have a right triangle. So 3 squared is equal to 2 squared plus this missing piece we don't know squared. We'll call it a. So 9 equals 4 plus a squared. Subtracting 4 from both sides, 9 minus 4 equal a squared. So 5 equals a squared. And then taking the square root of both sides, a equals square root of 5. So that side has a value, square root of 5. So now looking at this triangle, what is the cosine of this triangle? The cosine is going to be adjacent over hypotenuse. So the cosine is going to be square root of 5 over 3. So that is indeed our answer, square root of 5 over 3. That's the case you have to be leery of when you're working with inverse functions for the trigonometric ratios. Now, the last part is just to solve working with a right triangle. So in order to solve working with a right triangle, let's put a triangle here and let's label it. We have our various points on the triangle. This is D, this is E, and this is F. And always across from these angles we have the smaller letters. Those represent the legs. So this would be little d across from the angle D. This is little e, or the hypotenuse. And this is little f across from the angle F. So if we have a triangle set up like this, and we have F is equal to 17, D, or E, excuse me, is equal to 32. We want to find E, big E. So we want to find that angle E. Excuse me, not E, I'm sorry. We want to find D. So F is 17, E is 32. Find angle D. So anytime we're looking for this angle D, that would be this angle. We have the values for F and E. So F is 17 and E is 32. And so based on that relationship, since we have an adjacent side in the hypotenuse, we're going to use cosine. So cosine of the angle we don't know, which we'll call, I don't know why I called it X. We need to call it D. So let's change that to D instead. That makes more sense. So cosine of that angle, D, is equal to F over E. That's by definition. And we know F and E. We're given that in the problem. F is 32 and E is 17. And remember, to solve for D, we have to divide by cosine. So that means the inverse cosine is 32 over 17. So it's the inverse cosine of 32 over 17. Remember, by definition, inverse cosine is what? Same as cosine, 32 over 17. But you can put it in as inverse cosine on your calculator. So you want to go ahead and take this and punch it into your calculator. So it's going to give us the angle for D. If you punch that in, 57.9 is the approximate angle for D. So you have to use your calculator. So in working with these, make sure you understand the relationships, make sure you can find the ratios, and make sure you understand what inverse does to a trigonometric ratio.